Hello, welcome students to Sube channel. Today I am going to discuss question number 39 of 2020 physics paper MCQ part. First of all, I would like to thank all the students who subscribed to my channel. Some of them had messaged me, but there was no place for me to thank them. Therefore, I commonly thank all of you. So thank you very much. So this question is about Young's modulus. The theory parts we learn in the lesson called elasticity. So Young's modulus is a crucial mechanical property in engineering. It is very important in engineering as it defines the stiffness of a material such as steel when we design a bridge or buildings, and tells us how much it will deform for an applied stress. So the question, a metal wire of length 2 meter and cross-sectional area 5 square millimeter is rigidly clamped at 2 points A and B, which are 2 meter apart in the same horizontal plane. Then a block of mass 2.4 kilogram is hung from the midpoint of the wire as shown in the figure. So this mass is hung at the middle. The midpoint of the wire sags 2.0 centimeters. Sags 2.0 centimeter. From the initial position means this level. From the initial position and the total extension of the wire is 0.04 centimeter. Total extension of the wire. Total extension means the total length. Initial length is this one. Initial length is this one. So after the final length is this one. So the difference is the extension, that is 0.04 centimeter. Not this value, the extension. Initially the wire was horizontally placed like this. So this length, say L1, and after finally after this incidence, finally what happened, the shape of the wire is like this. So then the total length from here to here, say L2, then L2 minus L1 is 0.04 centimeter. That is the meaning of this statement. So first of all, we should properly understand the question. Then what will be the approximate value of Young's modulus of the metal? So they ask Young's modulus. To find out Young's modulus, we have to use lot of mathematics here. because there are two triangles, symmetrical and equal. So it is enough if you use only one triangle. You can use whatever you like. I would like to use this triangle, the right side one. So let us draw it so that we can write description information. So the triangle, the right side one is like this. So this length is given, the second 2 centimeter. 2 centimeter we have to convert to meter, 10 power minus 2 meter. So this side 1 meter, 1 meter, because the total wire is 2 meter. We take only this part, half of it, so it is 1 meter. Then total this length is not given, but the extension is this one. Total extension is 0.04 centimeter. That means 0.04 centimeter total. Total E extension. The half we have to take half of it, because we consider only this half. Then it is 0.02 centimeter. To convert it to meter, 0.02 times 10 minus 2 meter. So the length then of this side is, initially it was 1 meter, the extension is this one, so 1.02 we have to write this like this, 0.0002 meter. Here minus 2, therefore 1 2 decimal point comes here, so 1 2 3 zeros and 2. So this is the extension in meter. So 1.0002 meter is the length of this side. Then triangle is okay. Now we have to consider forces, because Young's modulus equals F divided by area, force divided by area, whole thing divided by E over L. L is the initial length. So initial length we know this one. Extension E we know 0.0002 meter. This part, that is the extension. So cross-sectional area is it given? Yes, this one, it is also given. if we found the force, we can easily find Young's modulus. So extension E we know, initial length we know, this one, cross-sectional area we know. Only the problem is now we have to find this F. F is what F? Here the force that was applied to, that was used to increase the length of this wire. So earlier this wire was like this. This wire was like this. After the force applied, what happened? It became like this. The length increased. But if it rotate without increasing the length, it will stay here. It would have to stay here. It would have to stay here, like this. We can draw a perpendicular like that. Or we can draw an arc, because we can take radian like that. The wire, initial wire, if it were not increased the length, the wire should have come to this place. But due to the force, it increased its length like this amount. Understood? So this angle we can take as theta. This part of this part equal to this one. There's no much difference. You see, there's no much difference. We can take this value for this length, because they want approximate value. Then we can write radian theta equals this S. So this one is 1 meter. S divided by 1. This angle is very small. This angle is very small. So if the angles are very small, we can equate this to sin theta. So sin theta equals S. This part we use now. Sin theta equals S. So if we draw a parallel line to this one from here like this, no? This angle also is theta. We want 10 because Now we are going to find out the tension. To increase the length of the wire, the force influenced is this tension. T. Due to the tension, earlier the wire was like this, then tension applied, so the wire, the length increased to this level. So therefore we have to find it by the methods we know about force. So the force directly vertically applied, this amount 2.4 kilogram is 24 Newton. So to balance it, because now no motion, it is stationary there without any motion, so this force must be balanced by some other forces. So the reaction of this wire's tension is this way, like this, from the other wire like this way, T. So 24 Newton equals T sin theta to this side, horizontally, vertically up, this angle is theta, so we have to turn this force to this way, so sin theta, T sin theta plus this T sin theta, again this angle is theta, T sin theta plus T sin theta, so 2T sin theta equals 24, then T sin theta equals 24 divided by 2, 12. T, instead of sin theta we can apply S equals 12. So instead of S we can use this value, because both these lines are approximately same in length. Therefore, because if we draw the triangle into a scale, it will look like this. So here you can't see any difference. We have magnified this diagram for the convenience, therefore that should keep in our mind. Therefore these lines are same in length, so we can substitute without exponential. Let us use it 0 point, the decimal point is here now, 0.2 meter, T 0.02 equals 12. Otherwise we can use with exponential, it would be easier. 2 times 10 minus 2 equals 12. The tension is then 6 multiplied by 10 power 2, 600 Newton. Now we know the tension, so F, not F, so this one is the F actually. So Young's modulus now equals F divided by A whole thing divided by E over L. So we can simplify F, we can take A to the denominator, then A here, E, L goes to the numerator here. So F we know 600, L initial length we know 1 meter, so that we don't have to write, divided by A cross-sectional area 5 square millimeter. 5, how to convert square millimeter into square meter? So 1 square meter, so there are how many millimeters? There are 1000 millimeter. This side also contain 1000 millimeter. So all 1000 into 1000, 10 power 6. So 10 power 6 minus 6. So it is the area in square meter. Then extension of one wire, extension of one wire is this one. Zero point 0002. So 600, 5 times 10 minus 6. This one again we convert 1, 2, 3, 4. 2 times minus 4. Then 600, we can simplify 1, 2, 0. 120, again divide by 2. We take this to the numerator, then 10 power positive plus 6, 10 power plus 4, then 60 times 10 power 10. With this 0, 6 times 10 power 11 Newton per square meter. That must be the answer. 6 power, this one is the answer. So dear children, I think you understood how I solved this problem. I took a lot of time because I know a lot of children can't understand this lesson. Everybody says elasticity is very difficult, Young's modulus is very difficult. Therefore, I explained how to solve this question, saying word by word. Now time is early morning, 2 o'clock. I chose this time because no disturbances, very silent the environment. So thank you very much for following my videos. Keep following, continue it. I will help you, so you can help me too by subscribing if you haven't still subscribed. Thank you very much. See you soon.